What's up? What is going on? It's coming close to Thanksgiving, so let's be thankful and talk a little more trig. We have four kinds of formulas that we are going to look at tonight. Right? The first type of formula is called a double angle formula. Okay? And what these formulas will do for us is it will allow us to take the values that we know on the unit circle and to find other values without too much trouble. Okay? So, remember our unit circle. Okay. If I wanted, let's say, just kidding. If I wanted sine of 120 degrees, okay, we can look that up on our unit circle, because 120 degrees is 2 pi over 3, right, which happens right here. Okay. So we could look that up and say, all right, the sine value is square root of 3 over 2. Okay. All right. But what if we didn't know that unit circle? Right? Here is the double angle formulas. We have two of them, one for sine and one for cosine. Right? So if I have sine of, let's call the angle 2x, that's the same thing as 2 times sine of x cosine of x. Right? And cosine of 2x is the same thing as 1 minus 2 times sine squared x. Okay, so, whoops, just kidding. Let's see, let me get rid of that. So sine of 120 degrees, that's the same thing as sine of 2 times 60 degrees. Okay. And then if we use that in my formula, it'll be 2 times sine of 60 degrees times cosine of 60 degrees. Right. And then we can read these off the unit circle in that first quadrant. Right. Sine of 60 degrees, or pi over 3, that's the same thing as square root of 3 over 2. Cosine of pi over 3, or 60 degrees, is 1/2. If you multiply that together, you get 2 times the square root of 3 over 2 times 2. Those 2's will cancel, and we get the square root of 3 over 2, which we knew from right there. Okay. All right, well, what if we have something which isn't quite on our unit circle? Right. We'll look at some of those in a second, but let's do a few more examples. Okay, so if I wanted to do a cosine example, right, what if I wanted cosine of, oh gosh, how about 270 degrees? Okay, that one's kind of boring because it's right there, right? And just by looking at the unit circle, we know the answer is supposed to be 0. Okay? Does our double angle formula actually back that up? Right? Well, 270 degrees is the same thing as 2 times 135 degrees. Okay? And if we use our formula, that's 1 minus 2 times sine of 135 degrees, right, squared. Okay? Well, sine of 135 degrees, if you look right there, is negative square root of 2 over 2. Okay? Oh, and don't forget about this 2 that's out front. I almost forgot about that. Okay? So it's 2 times sine squared, so let's make sure that we square this thing as well. Okay? So that's 1 minus 2 times, let's see, that'll be 2 over 4. So that's 1 minus 2 times 1/2, which is 1 minus 1, which does give us 0. Okay. All right, so again, if we know the entire unit circle, this isn't too handy because we can just look it up on the unit circle. But if we don't know the unit circle, if we just know that first quadrant, it can be pretty handy. Okay, so that's our double angle formulas. Let's look at a different style now. That's called the half angle formulas. Okay, so for example, what if I wanted something that's a little off the beaten path here. How about sine of 105 degrees? Okay. Well, here's what the half angle formulas say. Right? Again, we have one for sine and one for cosine. So if I have sine of 1/2 x, or if I have cosine of 1/2 x, right, then that's either plus or minus the square root of 1 minus cosine x over 2. Right? All that's under the square root. And this is plus or minus the square root of 1 plus cosine of x over 2, like that. Okay. Again, it's all under my square root. So 105 degrees, I could write this as sine of 1/2 times 210 degrees. Okay? Because again, half of 210 gives me 105. Okay? And the plus or minus, right, what you need to try to figure out is which quadrant are you in. And that'll tell you when to use a positive and when to use a minus. Okay? All right, so 210 degrees, that is quadrant 3. And in quadrant 3, sine is negative and cosine's negative. Okay? So if I keep on using this formula, it'll be the square root of 1 plus cosine of 210 degrees all over 2. And here, cosine of 210 degrees is negative square root of 3 over 2, and then that's all over 2. And these can get a little bit messy to figure out or to clean up. Okay, but in the numerator, I could write this 1 right here as 2 over 2, right? And then that'll be minus square root of 3 over 2, all over 2. Right? So then I get 2 minus the square root of 3 over 2 up top, and then that's still over 2. And if we simplify this, that's 2 minus the square root of 3 over 4. Okay? So it's a little bit of a different answer for us. Okay? But again, the half angle formula is this. Half angle formula for cosine is that. So these are just the formulas we need to kind of write down on a piece of paper there and have those ready to go. Okay. Here's another style for you. This is the sum formula. Right? Because in the past we've often wondered if we could do this, right? Like if I had the sine of x plus y, could I write that as the sine of x plus the sine of y? Right? And every single time we said no, we can't break it apart like that. Okay? Well, we do have formulas that we can use to break it apart, but it's not inherently obvious as to what it's going to be. Okay? So sine of x plus y, we can write as sine of x cosine of y plus cosine of x times sine of y. And for cosine, cosine of x plus y is cosine of x cosine of y minus sine of x sine of y. All right? So if I wanted sine of 75 degrees, what I want to do is come up with two formulas that I know that add up to be 75 degrees. For instance, 75 degrees is 30 degrees plus 45 degrees. Right? So if I call this one x and if I call this one y, then this formula becomes sine of 30 degrees times cosine of 45 degrees plus cosine of 30 degrees times sine of y, which is 45 degrees. Right? Just took these values and plugged it right into this, whoops, not this one, but into this formula right here. Okay? And now these are values we know on the unit circle. Sine of 30 degrees is 1/2. Cosine of 45 degrees is square root of 2 over 2. Cosine of 30 degrees is square root of 3 over 2. And sine of 45 degrees is square root of 2 over 2. So this is square root of 2 over 4 plus the square root of 6 over 4, which is just square root of 2 plus the square root of 6 all over 4. Okay? So that gave me a formula or a value that I didn't know before, but by using this sum formula, we could figure it out. Okay? What about one for cosine? Now let me clean some stuff up here. So cosine of 120 degrees. We could do this in a couple of ways. I could make it 30 and 90 or 60 and 60. So let's do this. Let's write it as cosine of, how about 60 degrees plus, that'll be too easy, right? Because that might be easy to see. So let's actually write them a little bit differently. Let's write them as 30 degrees plus 90 degrees. Okay? And if I use this formula for cosine, right, this will become cosine of 30 degrees, right, just plug it right into there, times cosine of 90 degrees, right, plug it right into there, minus sine of my first one, right, 30 degrees, times sine of my second one, which is 90 degrees. Okay? Cosine of 30 is square root of 3 over 2 times cosine of 90 is 0. Let's see, sine of 30 degrees is 1/2 and sine of 90 degrees is 1. So this gives me a negative 1/2. Okay? And if you think about 120 degrees, that's an angle that looks like this right there. So there's 120 degrees. The reference angle right here is 30 degrees. So this is the same thing as cosine of 30 degrees. Did I do that right? Cosine of 30 degrees with the right plus or minus sign on there. Right, so we get a minus 1/2 with that one. Okay, so we have these two forms we can come up with if we want to get a different type of a sum. Another example could be, how about cosine of 105 degrees? Right. Again, we can use a reference angle to figure this one out for me. Okay. There's 105 degrees right there, which means my, cosine of 105 degrees, which means the the reference angle right here is 65 degrees. So this process really isn't going to work for us at all, which is why this formula can be kind of handy. Because I could write this as cosine of 60 degrees plus 45 degrees. And using this formula, that's cosine of 60 degrees times cosine of 45 degrees minus sine of 60 degrees, sine of 45 degrees, which is 1/2 square root of 2 over 2, square root of 3 over 2, square root of 2 over 2, so that's square root of 2 over 4, square root of 6 over 4, which combines into that. Okay. So again, we could come up with this kind of a strange angle using this sum formula. Okay. One more style of formula we're going to look at is a difference formula. And again, we'll look at sine and cosine. So if I had sine of x minus y, that's going to be sine x cosine y minus cosine x sine y. And cosine of x minus y is cosine x cosine of y plus sine x times sine y. All right. So what if I wanted something strange like cosine of 15 degrees? Not on the unit circle, but 15 degrees is the same thing as 60 degrees minus 45 degrees. So I could use this difference formula. Okay? And this will give me cosine of 60 degrees, cosine of 45 degrees, minus sine of 60 degrees, sine of 45 degrees. Okay? So this is a 1/2 times the square root of 2 over 2 minus, let's see, sine of 60 is square root of 3 over 2, and that's square root of 2 over 2. Of course, I could actually write down the formula correctly, right, because it's supposed to be a plus right there. So let's make this a plus. That's a plus. So that's square root of 2 over 4 plus the square root of 6 over 4, which combines into one fraction to give me that. Okay, so to sum up, we have 4 different styles of formulas that we need to write down. So make a sheet of paper and put these things on here. Right? We have the double angle formulas, sine 2x and cosine of 2x. Right? That's 2 times sine x cosine x, and this is 1 minus 2 sine squared x. Right? We had, so again, these are called my double angle formulas. Then the half angle formulas were sine of 1/2 x and cosine of 1/2 x. That was plus or minus the square root of 1 minus cosine of x over 2, and this is plus or minus the square root of 1 plus cosine of x all over 2. Right? Those two, again, are called the half angle formulas, right? Because we're multiplying them by a half. Right? We have the sum formulas, which technically the term is called sum to product formulas. Right? So if I have this sum sine of x plus y or cosine of x plus y, I could write them out as a multiplication problem. Right? This is sine of x cosine of y plus cosine of x sine of y, and this one is cosine x cosine of y minus sine of x sine of y. And the last style we learned was the difference formulas, right, or difference to product formulas, which was sine of x minus y and cosine of x minus y. Right? This is sine of x cosine of y minus cosine of x sine of y, and this one is cosine x cosine of y plus sine of x sine of y. Okay, so again, make a sheet, write these down, because we're going to be using them all day long in class on Monday. Okay, so that's it. I will see you all tomorrow. Hope you have a great night.